Determine the force required to produce an extension of 1 mm in steel wire of length 2 meter and diameter 1 millimeter. Given Young's modulus for steel, Y is equal to 2 into 10 to the power 11 Newton per meter square. In the problem, extension X is given, length of the wire capital L is given, diameter of the wire small d is given, and from the diameter we can calculate radius using the formula R is equal to d by 2. And we have the expression for Young's modulus as Y is equal to FL by AX, where A is the area of cross section of the wire and A is given by pi r square. Thus F becomes equal to pi r square Yx by L. Substitute the values after proper conversion to SI units, and we get Y is equal to 78.54. Next, calculate the torque required to twist a wire of length 1.5 meter, radius 0.0425 into 10 to the power minus 2 meter through an angle of pi by 45 radian if the value of rigidity modulus of its material is 8.3 into 10 to the power 10 Newton per meter square. Once again, length of the wire L is given, radius of the wire R is given, and angle of twist theta is given. Couple per unit twist C is equal to pi into N R to the power 4 by 2 by L, and that gives the value of C as 2.8357 into 10 to the power minus 3. And torque required tau is equal to C into theta. Substitute the values 2.8357 into 10 to the power minus 3 into theta is equal to pi by 45. After simplification, we get torque is equal to 1.98 into 10 to the power minus 4 Newton per Newton meter. Next problem. Calculate the extension produced in a wire of length 2 meter and radius 0.013 into 10 to the power minus 2 meter due to a force of 14.7 Newton applied along its length. Young's modulus of the material of the wire Y is equal to 2.1 into 10 to the power 11 Newton per meter square. Once again, in this problem, length of the wire capital L is given, radius of the wire capital R is given, Young's modulus of the material Y is given, applied force F is also given. Use the formula Y is equal to FL by AX, where A is the area of cross section and A is equal to pi r square, and the rearrangement of the terms gives us extension X is equal to F into L divided by A into Y, or F into L divided by Y into pi r square. Substitute the values and simplify. We will get X is equal to 2.6 into 10 to the power minus 3 meter.